Okay, welcome to this part on our chapter on MRP and ERP. And what I'm going to be doing in this part is to go through the MRP explosion and netting, and also go through the MRP backward scheduling. So let's take a look at this diagram here. We have a bill of material where we're producing a Part A, and to produce Part A, it requires 2 Part B's, and it requires 3 Part C, and 1 Part D, and 4 Part E. And then to produce the Part B requires 2 Part E's and 2 Part F's, and then finally to produce Part D requires 3 Part E. If you take a look at the table up at the top, you can see that I've listed all the parts, and there's 2 columns to the right of that. One is how much inventory we currently have of each of these parts, and the last column shows the lead time, how long it takes to either produce this part or to get this part from a supplier if we're buying that. So there are 4 questions that are shown in the upper left-hand corner. The first question is, how many E's will be needed to make 1A if there were no inventory for any of these materials? So in this first one right here, we're going to assume that that inventory amount is 0, and just answer the question, how many E's would be needed to make 1A? So once again, we're answering the question, how many Part E's are going to be needed to make 1A if there's no inventory? Well, let's first take a look at the bill of material, and let's look where all the places where E's are needed. So you notice that we have, to make A, we need some B's, but in order to make a B, we need some E's. So we see that there is a path from A through B and then down to E. We also have another path where we go from A to Part D, and then D requires some E's as well. And then we finally have a third path where we have E's that are used directly into making Part A. So we're going to have to calculate what the demand will be. Another way of saying that is what the dependent demand will be going down all 3 of these paths. Now here's the way that we do it. We assume that for Part A we're making 1. So we're going to first go through the path A to B through E. So to make 1A is going to require 2 B's. And I put a little box down here at the bottom. 1A times 2 B's is equal to 2. But then to make 1B is going to require 2 E's. So we're going to take that 2 and multiply it times another 2, which is for the E's. So we're going to end up with 4 E's going down this path A through B through E. Let me go through that again. We're going to multiply 1 times 2 B's. 1 times 2 is 2. And then we're going to keep that 2 and then multiply it times the 2 E's. So 2 times 2 is 4. So let's take another path. Another path is we'll go from A through D through E. And going through the same method, 1A times 1D is 1. We'll keep that 1. And then we're going to multiply that 1 times 3 E's. So 1 times 3 is 3 E's going through this path. And then finally we have a third path, which is from A to E directly. So 1 times 4 is 4, so there's 4 E's required in that final path. Now we're just going to add these numbers together. So how many E's does it take to make 1A? It takes 4 plus 3 plus another 4, which is a total of 11 E's in order to make 1A. if there is no inventory. Now, I know that this might seem a little confusing to you. If it does, just go ahead and pause this lecture and rewind it and go through it again. Now we're going to move forward to the second question. And the second question is, using the inventory information in the table shown, how many E's are going to be needed to make 10 A's? So we refer to this as doing an explosion and netting, N-E-T-T-I-N-G, which basically means that we are taking into consideration any inventories that we have. So what I've done is I've put a little formula just to the above and to the right of the letter A, and the formula is the net required quantity is equal to the gross required quantity minus any inventory. And we can think of that little formula as being very similar to our most recent paycheck that we might get. So our net pay on our paycheck is equal to our gross pay minus any deductions that we have. So this is a very similar formula that we might see that. So using that formula, we're going to start, as we always do with MRP Explosion, with the finished product, which is part A. So the question says, how many E's are needed to make 10 A's? So the 10 is going to be our gross requirement for A's. If we take a look at the table above and we look over from part A, we see that we have 5 A's that are in inventory. So we're going to use those 5 A's to partially satisfy this demand for 10 A's, which means that we have a net required of 5 A's. So once again, we need to make 10. We have 5 completed in inventory. We're going to use those 5, and then we need to make an additional 5 A's. So as we saw in the previous question, we have E's along 3 different paths. We have it from the path A to B to E, and also A to D to E, and then finally from A to E. So we're going to have to go through each path and do this calculation. Now this net required of 5 A's, we're going to carry that 5 down to the next level in the bill of material, which is going to be for part B. So if we have to make 5 A's, how many B's are going to be required? Well, it's going to be 5 times 2 B's. So you'll notice I put a little box in. So the net required for B's are going to be the 5 A's times 2 B's. That's equal to 10. But if we look at the inventory that we have for B's, we have 3 in inventory. So therefore, our net required for B's will be 7 B's. So once again, the calculation is 5 A's times 2 B's is 10. We have 3 B's in inventory. We'll use those, and we end up with a net required of 7 B's. Now we're going to take those 7 B's, the net required, and carry it down to the next level of the bill of material. So in order to make 7 B's, how many E's will be required? Well, it takes 2 E's to make 1 B. So to make 7 will be 7 times 2, which is 14. And we have 7 E's in inventory. We'll use up those 7 that are in inventory and leave us with a net required of 7 E's. Now we'll do a very similar thing going through the next path where we have E's, which is going to be the A to D to E path. So again, for A, we have a net required of 5. So 5 times 1D to make 1A. So that's 5 D's. But if we look at our inventory for D's, we see we have 4. So we have 5 minus 4. That means we need to make 1 additional D. Now that one additional D, we're going to carry it down to the next level. So to make 1D, how many E's will be required? That would be 1 times 3 minus our inventory for E's. Now we only have 7 E's in inventory, so we can only use them one time in our calculations, and we've already used up the 7 E's when we had gone through the path A to B to E. So essentially we have no more E's that we could use to satisfy D's, so therefore the inventory is 0, and it takes 3 E's in order to make the 5 A's going through the path A to D to E. Finally, we'll go through our last path, which is from A to D directly. So to make 5 A's, how many E's will be required? It takes 4 E's to make 5 A's, so that's 5 times 4, which is 20. And again, we're going to subtract our inventory, but once again, we have already used up our inventory for E's, so we have no more inventory. So we have 5 times 4, or 20. And now we're going to add up the 3 numbers. So we have 7 E's going through the path to the left. We have 3 E's going through the path through the middle. And we have 20 E's going through the path on the right side of the bill of material. We'll add those up. So therefore, the answer is it takes 30 E's to make 10 A's. So once again, these calculations might look a little strange to you. If you need to, go ahead and pause this recording and back it up and go through it. Okay, so number 1 and number 2 were MRP calculations, where MRP is going to calculate what the dependent demand is going to be. But MRP does other things besides calculations. What it also does is to do scheduling. And scheduling is determining the when something needs to be done, the time when something needs to be done. So in number 3, we're going to be doing some MRP backward scheduling. So what I've done is I've added to the bill of material diagram in the small boxes just to the side of the letters what the lead time is. And I'm getting this information from the right-hand column up at the top. So we can see that it takes 1 time period, the lead time, in order to take the B's and the D's and the E's and convert them into A's. And it takes 2 time periods, the lead time, for the B's, in other words, to take the E's and the F's that are needed to make the B's and convert them into a B. And then finally we have D's, and it takes 1 time period for the D's in order to convert the E's into a D. Now the question that we want to answer is number 3 in the upper left-hand corner. And the question is, using the lead time information in the table, when would part F be needed to deliver an order for A in time period 10? Now before we go through this, I just want to tell you that the little tricks that we were doing in answering questions 1 and 2 when we were multiplying, we're not going to be doing any multiplying. All we're going to be doing is basic subtraction when we're determining the when, the timing, the scheduling when MRP needs to do anything. So let's kind of forget about that multiplying trick that we were doing in number 1 and number 2. Now, since part F is only used one place, it's used in the path from A to B to F, okay? We really don't need to consider any of the other things, so we'll just keep it simple. All we have to do is to do from A to B to F. So A is needed in time period 10. and it takes one time period to take the B's and the C's and the D's and the E's and convert them into A. So when is part B needed? Part B is needed in time period 9. So how did I come up with time period 9? It's just a question of time period 10 minus 1 time period for the lead time. So 10 minus 1 is 9. Notice we didn't do any multiplication. All we did was just simple subtraction. So we know that part B is needed in time period 9. The question asked is, when is part F needed? So it takes 2 time periods to take E's and F's and convert them into B. So when are F's needed? They're needed in time period 7. How did I get 7? I just subtracted time period 9 minus the 2 time periods required to take the E's and the F's and convert them into B's, or 9 minus 2 is 7. So this is backwards scheduling. This is what MRP will do to determine the timing of when something needs to be done. So once again, if you need to pause this recording and rewind it and go through this again, go ahead and do so. Now we're going to do one final thing on this little exercise here, and that is going to be number 4 in the list. And the question is, what is the cumulative product lead time? And the definition of the cumulative product lead time is this. What is the longest path, taking into consideration all the lead times? And another way of defining cumulative product lead time would be, if I had no inventory of any item, how long would it take to produce the first item? How long would it take to produce the first A, in other words, if I had no inventory of A's or B's or C's or anything? So to answer this question, what I'm going to be doing is I'm going to be adding the lead time of every part through every particular path. So you'll notice that what I've added to the diagram is I've added the lead time for every part. It's shown in a little box over to the side of the part. So how many paths do we have in this bill of material? Well, we have a path from A to B to E. So to add the lead times for that path, that would be 1 for part A. It would be 2 periods for part B. And then finally, to get part E from a supplier requires 2 time periods. So the sum of that path would be 1 plus 2 plus another 2, or 5. We have another path that goes from A to B through F. So similarly, we're going to add the times for it, which would be 1, 2 time periods for B, and 3 time periods for F. So 1 plus 2 plus 3, as shown in the lower left-hand corner, is 6. We have another path from A to C. Adding the times for that, we have 1 plus 1 equals 2. We have another path from A to D to E. So adding those times together, we'll have 1 plus 1 for D. And then for E, we have another 2. So 1 plus 1 plus 2 is equal to 4. And then finally, the last path is from A to E directly. And adding those times will be 1 plus 2 is equal to 3. I see there's a small error on this thing. That should be 1 plus 2 equals 3, not 1 plus 2 plus 2. It should be 1 plus 2 equals 3. So now examining all these paths and looking at the total time for each path, we can see that the path A through B through F is the longest path, and that path is 6 time periods. So therefore, the answer to the question, what is the cumulative product lead time? The answer is 6 time periods. So in other words, if I had no inventory of any part, how long would it take me to produce the first A? And the answer is it would take me 6 time periods to produce the first A. This concludes this lesson.